Video number 2 for sample test IV. Number 4. This is still non-calculator. You could have one there if you want, but you really shouldn't be using it. So let's do this. Let R be the region in the fourth quadrant. That's interesting. They usually say first quadrant, but fourth quadrant. That's different. Enclosed by the x-axis and the curve y equals x squared minus 2kx, where k is greater than 0. If the area of the region of R is 36, then the value of k is. Okay, so they give us the area. And we know that area is going to be the integral, like this. And they even tell us that we're going, we don't know what A and B are. We've got to figure that out. Okay. And we have this curve here, x squared minus 2kx dx. And we know that this area is going to be equal to 36, so it says. So we need to think about how this picture even looks, especially if we're in the fourth quadrant. That's pretty crazy there. Okay, well, x squared minus 2kx. So let's say I wanted to plot x squared minus 2kx. Let's give ourselves some x and y axes. I know I'm in the fourth quadrant, so something's going on with that. I do notice a couple of things. I could kind of factor this, x squared minus 2kx. That's like x times x minus 2k. So if I were to think about my x-intercepts, if I were to set that equal to 0, that means I have an x-intercept here at 0 and another x-intercept here at 2k. And it's just a graph that, let's do some fancy graphing. How about this? Oh, that's not what I wanted. There we go. It's going to look something kind of like that. So we're trying to find this area. Now, I'm guessing that they're just asking for the area, meaning that it's not really going to be negative. So we're going to be taking the absolute value of whatever number we were to get in here. I do realize that my A and B, if I'm enclosed by the x-axis here and this curve, that means that A here, A equals 0, and B equals 2k. So now I can kind of set this up and evaluate it a little bit differently. So A equals 0. And b equals 2k, and I have x squared minus 2kx, and then we have that equal to 36. Now that I'm here, I can actually just set it up and simplify, do some algebra, and solve backwards for k. So I first take the antiderivative. That's going to help me get rid of this integral representation. So then I'll have x cubed over 3 minus 2k x squared over 2. We're going to evaluate that from 0 to 2k, and then we have that equals 36. So let's give ourselves some space, do some algebra. First of all, notice that both these terms have an x, and if I were to plug in 0, that would just make that second half of the top minus bottom go to 0. So I'm going to have a bunch of stuff minus 0 equals 36. So let's figure out what this stuff would be. First, 2k cubed. That's going to be 8k cubed over 3. And the second half here, 2k times 2k squared. Well, that's actually the same thing as what I just did. It's 2k times 2k times 2k. So that's, again, going to be 8k squared. And then we have over 2 minus 0 equals 36. I would love to simplify this. Why? Because it's kind of weird having two fractions so similar but not exactly. So this is what I'm going to do. I'm going to factor out an 8k cubed. And then I got to figure out inside here what is 1/3 minus 1/2. That's where we're going with this. Now, I would get a negative value. I know that, but I'm going to be taking the absolute value of it. So I should be thinking I'm going to take the absolute value of this. Why? Because we're talking about this area. I know it's going to be negative 36, but it's really asking me for just the area, not the actual value, just the area meaning non-negative. Okay, so we have 8k cubed, and we got this fraction 1/3 minus 1/2. That's really like 2/6 minus 3/6, which equals negative 1/6. So we got 8k cubed divided by 6 equals 36. Well, I can simplify that a little bit. 8 and 6 really becomes 4 and 3. So then I have, let's go ahead and continue this over here. 4/3 k cubed equals 36. And what did I do there? This was negative, but I'm taking the absolute value of it. And the absolute value of that negative is going to make it positive. Well, if I multiply both sides by 3/4 times 3/4, 1/4 of 36 is 9. 3 of those is 27. So k cubed equals 27. Wow, k equals 3. That was a lot of crazy around the side door kind of action, because when you look at this, it's like we did so much algebra just to find something very simple. Now here is a little strategy you guys could have tried. You see how simple these answers are? You could have just plugged them in. And you probably would have started with A, and by the time you got to B, you would have got your answer. That's a strategy you could have used. It is a gamble, but hey, sometimes gambles pay off. Let's look at number 11. The minimum value. Minimum value. Look, it's asking for the value, not what x gives the min. It's saying that's not what it says. It says what is the minimum value. That means we're talking about the y value or the f of x part. So we actually got to find where it is, then plug it back in. So that means we got to do derivative. F prime of x equals e to the x minus 2x. Why? Because the min is going to happen at some critical point where the function flattens out or peaks, and we only see that kind of stuff when we look at the derivative. Oh, whoops, I didn't even take the derivative. I meant to, but I kind of screwed it. There. Okay, so we got e to the x minus 2. Wow, that wasn't that much different. Because the derivative of e to the x is just e to the x. And the derivative of minus 2x is just negative 2. So I got to set that equal to 0. E to the x minus 2. That gives me 2 equals e to the x. That was a sloppy e. E to the x. Take the natural log of both sides. Then I get x equals natural log of 2. So that's my x value. But I know that's not what I'm supposed to do. You got to be careful here. This is tricky verbiage. A is not the answer. So forget about it. What I'm looking for is the y value, which is what I get when I plug in natural log of 2. So that's going to be e to the natural log of 2 minus 2 times natural log of 2. Well, e to the natural log of 2 is really 2. And we got minus 2 natural log of 2. Wow, that's a lot of 2's. But I could factor out one of the 2's. It becomes 2 times 1 minus natural log of 2. Boom. That just happened. The graph of y equals f of x in the closed interval is shown in the figure below. For me, it's above for you. If f is continuous on negative 3, 7 and differentiable, then there exists a c between such that. Ooh. Okay, so here's what's happening here. It's saying that we're continuous and differentiable the whole time. In other words, there's no holes, there's no skipping. It's a smooth, connected line. That means that I could find the average slope, and if I were to compare this average slope to another place here, that somewhere it's also going to be parallel to that. So in other words, right about at this point here, the average slope equals the instant slope. Does anybody remember what theorem that was that kind of taught us about that? It's the mean value theorem. And the mean value theorem is saying that there does exist a c between the two endpoints such that the average slope equals the instant slope. Well, here's instant slope, instant slope, instant slope, instant slope. So it's saying that the instant slope, one of those, is equal to the average slope. Well, I hope that you can tell just by looking at this that it's not positive, and it's definitely not that steep. So it's got to be this one. Now, if the average change was 0, if we had a picture that looked like this, then our average slope would be 0. And the instant slope would be 0 here. That's kind of like Rolle's theorem, using derivatives to find critical points and stuff like that. Just to really prove to ourselves that the average slope is negative 1/5, let's figure it out here. That means that we got 4 minus 2 over negative 3 minus 7, which is 2 over negative 10 equals negative 1/5. Yes, it's true. Alright, if y equals 1 minus x over x minus 1, then dy dx is, oh my gosh, they're trying to be so tricky. Because some of these, it looks like this would be a hard problem, but it's not. You know why? Because 1 minus x equals negative times x minus 1. That means that I can substitute a little bit here. Y equals 1 minus x over negative 1 times 1 minus x. Those reduce, and I have 1 over negative 1. So y equals 1 over negative 1. This is a constant. The derivative of a constant is 0. Why? Because this is measuring the rate of change, and this does not change, hence the word constant. Next. Let f of x be continuous and differential function. Table below gives the value of f of x and f prime of x. Here's the original, here's the derivative. At several values, g of x equals 1 over x. What is the value of g prime of 2? Ooh. G of x equals 1 over f of x. Another way of thinking of that is f of x to the negative 1. So g prime of x is going to be a chain rule involving f of x. It will be negative 1 times f of x to negative 2 times f prime of x. So that means we have negative 1. If we're trying to find g prime of 2, that means it's going to be negative 1 times 1 over f of 2 times f prime of 2. Let's fill in these pieces. F of 2 is really 8. So this is going to be 1 over negative 8. Then f prime of 2 is negative 4. So times negative 4. 1, 2, 3 negatives, so the answer is going to be negative. Wow, is it really that easy? No, it can't. Something's missing. Oh, this is squared. So that's going to be negative 8 squared. So it's not positive, or not negative, it's positive. So f of 2 squared is negative 8 squared. So that's negative 1 times negative 4, which is 4 over 64. And 4 goes into 64 16 times? Yeah, 1 over 16. Boom. Pause it if you want. I'm moving on. Number 15 is approximated by 3 circumscribed rectangles of equal width. Boom, boom, boom. On the x-axis, then the approximation is. Okay, the key word here is circumscribed. So what does that mean? What does it mean when something's circumscribed? Sorry about that, I had a quick interruption. Anyways, circumscribed, what were we doing? Oh yeah, we were trying to explain what circumscribed means. Okay, circumscribed is when you have a curve and the shape is inside. So I have this function here, natural log of x, and if you're thinking about the function natural log of x, hopefully you're thinking about a picture that looks like this. And if we're going from 1 to 7, that means we're in the range that is kind of from here. From 1 to 7 is going to be something like this. And if we're circumscribed, that means that we are going to be rectangles like this. So the area of this rectangle, first rectangle, is going to be 0. Since it's circumscribed, that means it's inside the curve. It's restricted on the inside. And this second one, it's going to be at these other intervals. We got 1, 7. We're splitting this into equal lengths. So right down the middle, what would that be? 4. So then on either side of this, that would be 3 and 5. That gives us equal lengths of 2. So this next one, this is going to be 3. This is going to be 5. So this height right here of the second one is natural log of 3. And the height of the next one is natural log of 5. So here we got natural log of 3, and here we got natural log of 5, times the width, which in each of these is 2. So this is 2 natural log of 3, 2 natural log of 5. So D would be our answer, because the area is equal to 2 times natural log of 3 plus 2 times natural log of 5. The key word here, circumscribed, means in, or no, I shouldn't say in, I should say it's more like restricted, within. These are pretty fast if you know the vocabulary. The volume of an expanding sphere. Whoa! Hold your horses there. The volume of an expanding sphere is increasing at a rate of. That sounds like related rates. Sure does. So it says the volume is increasing. That means that they just told me that dV dt equals 12. When the volume of the sphere is 36, so we know that volume equals 36 pi. How fast in square feet per second is the surface area increasing? Ooh, so they give us one to work with, but then we got to plug it into the other one. Well, let's see how this might work. In order to figure this one out, we need to figure out what is ds dt. ds dt at volume equals 36. We don't know what that is, but we're going to figure it out. So here we go. Volume is 36 pi, but I know that if I were to try and start with s equals 4 pi r squared, s equals 4 pi r squared. If I start with this and I take the derivative with respect to time of all of it, I'm going to get ds dt. That's not proper notation what I just did, but I'm just kind of trying to save space here, guys. So then we have the derivative of this right side. 4 pi is a constant. That stays there. R squared is a function, so we take the derivative. 2r dr dt. Now we plug in what we know and then go from there to evaluate what ds dt equals. We don't know r. We don't know dr dt. We need those. So how do I find r? Do I have some equation, relationship with known values that I could find r? What's that? Did the pen just circle volume? Yes, it did. Okay, well we know volume equals 36 pi, so I'm going to put 36 pi in for v right there. That means that 36 pi equals 4/3 times pi r cubed. Wow, this sounds familiar. Like we just did something like this before where we had like something cancel out, and then we multiplied both sides by 3/4, and then we figured out that 3/4 of 36 was 27 equals something cubed, and that was 3. Huh, that's interesting. Like we just did that. Not that long ago. Actually, we did do that a few problems ago. So 3 equals r. Okay, that's easy enough. dV dt equals 12. Why would they tell me that? Oh, because I know r right here equals 12, but I do not know what dr dt is equal to. But I do know that v equals 4/3 pi r cubed, and dv dt, if I were to take the derivative of both sides with respect to t, is going to be 4/3 times 3 times pi r squared dr dt. And I know that r equals 3, and these 3's cancel out, so then I got 4 pi r squared dr dt. We're running out of space here. If I plug in 3 for r, that means that I'll get 4 pi times 3 squared dr dt equals dv dt. Wait a second. Wait a second. Don't I know dv dt? Ding, 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 ding. Yes, I do. 12. So over here I'm going to have 4 times 9, which is really 36. So I'm going to divide this side by 36 pi, and that reduces all of this. So I'm going to divide this side by 36 pi as well. So I got 1 over 3 pi. If I reduce that, equals dr dt. All right. Now I have the pieces that I need to plug in here. ds dt equals 4 pi times 2 times 3 is r times 1 over 3 pi is dr dt. So the 3's reduced. We got 8 pi over pi, so it's just 8. Wow. Is it really that simple? Man, look at how all that work came down to just that. 8. Next. 17. If f of x equals 15 minus g of x for negative 2 to 2, then negative 2 to 2 of f of x minus g of x is equal to. Let's see what we have going on here. I'm going to try and see if I can do some algebra with this, and then go from there. So I got f of x equals 15 minus g of x. I'm going to subtract 15 to both sides and subtract f of x to both sides. Do I really want to do that? No, I don't think I want to do that. I know that it has something to do with doing the algebra here. What I'm basically trying to do is get this similar to this here. Ooh. F of x equals 15 minus g of x. The integral of f of x minus g of x. Let's see if we can do that. If we were to do the integral, both sides, we got f of x equals 15 minus g of x. If I were to subtract g of x to both sides, you're looking at this. Do those cancel out? No, they don't. There's actually 2 of them now. So it's f of x minus g of x equals 15 minus 2 g of x. Now if we take the integral from both sides, ooh, this is looking pretty close. Let's see what we're going to get here. Well, the integral of 15 minus 2 g of x, we know what the integral of 15 is from negative 2 to 2. 15 is a flat line that's 15 high. And from negative 2 to 2, that would be 4 long. So that's a box of 60. So this area right here, that equals 60. So we got 60 minus 2 g of x inside an integral here. Is there anything that looks close to that? Oh, yes, there is. It's e. So let's see if I can give you guys a picture that shows where all that is. I'm going to restart this problem. now that I know where it's going. So we start with the original relationship, f of x equals 15 minus g of x. And if I subtract g of x to both sides, then I got f of x minus g of x equals 15 minus 2g of x. Now I'm going to integrate everything from negative 2 to 2. On the right side, I got what I want. So I basically just have to simplify, or on the left side, I got everything I want. I just need to simplify the right side to see what it's going to turn out to be as I evaluate the different pieces. I can split this up into two integrals. It's going to be the integral from negative 2 to 2 of 15 dx minus 2 times the integral from negative 2 to 2 of g of x. And this right here, this is really going to be 15x from negative 2 to 2 minus 2 times g of x, negative 2 to 2. And we didn't actually take the antiderivative of that one. So then if I were to plug in this, 15 times 2 is 30, minus 15 times negative 2 is negative 30, so that winds up being 60, minus 2g of x, but the 2g of x is still in the integral, from negative 2 to 2. So that's how we get e. So that's the algebraic way. I was thinking about it visually, but that's the algebraic way as well. Number 18, last video for now. Still kind of waiting for traffic to die down a little bit. Traffic sucks on Fridays. Okay, so d dt, 3t squared plus 2t minus 1. Wait a second. Wait a second. This is kind of interesting. They're saying take the derivative, then take the integral again. So you almost feel like things are going to reduce or cancel, but it would behoove you, that's an old school word there, to actually take the derivative of each of these terms, because this term is going to go to 0. So that's not going to count when we do our integral. So the derivative of 3t squared is going to be 6t, pardon me. Derivative of 2t is just plus 2. And we're going from 2 to 4, dt, and the derivative of negative 1 went to 0. So that part's not included anymore now. So when I take the antiderivative this time, it's going to be 3t squared plus 2t, and then we're going to evaluate it from 2 to 4. So when I plug in 4, it's going to be 3 times 4 squared plus 2 times 4. And then when we evaluate the bottom here, top minus bottom, it's going to be 3 times 2 squared minus 2 times 2. So 2 times 4 minus 2 times 2 is going to be 8 minus 4, so that's 4. And 3 times 16 minus 3 times 4 is really 3 times 12, which is 36. Minus 4 is 32. Oh, that's a negative. This would be 8 minus negative 4, so that's 12. 36 plus 12. Did you guys catch that? Let's see if you caught it. So if I were to write out each of these individually, I have 3 times 16 plus 8 minus 3 times 4. Then we got minus minus, so that's going to become plus 4. So these two make 12. And 3 times 16 minus 3 times 4 is really 3 times 12, which is 36. So we have 36 plus 12. That's going to equal 48. Is it? What am I missing here? Do I have to go all the way back and check? I want to do that. 2 squared is 4. 4 squared is 16. 3 and 3. This is a 3. 6t is going to become 6t squared over 2. 2t from 4 to 2. Should be getting 48. And we got this 8 and this 4. I know you guys are probably seeing something I'm not. Plug in 4, then we subtract that. What is 3 times 16? This is 48. That's 3 times 4, that's 12. 48 minus 12, that's 36. It's like 48 minus 12 and then plus 12, we should get 48. I get 48. Well, I'm sorry guys, if you see something I don't, I must be missing it here. But when you have the integral of a derivative, you're going to take the derivative first, and that's what I did here. So 6t plus 2, and then we take the antiderivative of that. I don't think this one has anything to do with what's going on. If it did for some reason, I'm guessing that we would have 4 and 2 plugged into just all of these. So we'd have a minus 1 somewhere in here. And because that's over a couple of lengths, then the answer would be 46. But I really don't think that that should matter. That's kind of crazy. C is my best guess. Alright, that's it for that video. See you in the next one.